All right, tape 234 is the law of sines and cosines. Now, what these rules will do for us is to solve any triangle. All right, so let's look at the first picture I have drawn, the notes. Any triangle. This also works with right triangles too. Okay, if you're using a right triangle, then you'd end up doing the sine of 90 degrees. But still, for any triangle, the law of sines says that in a triangle, the side opposite the angle, all right, says, now look at what it says. It says that the side opposite the sine of its angle is equal to another side opposite over the sine of the angle opposite that side. Now, in some textbooks, you will see A over sine of A equals B over sine of B equals C over sine of C. That's not what it's saying. It's saying, looking at all three of these, that A is to the sine of A as B is to the sine of B, or side A is to the sine of A as C is to the sine of C, or B is to B as C is to C. Any combination, any two sides, opposite angles, you can set up that ratio. So in any triangle, you can solve it with side A over sine of the angle opposite that side, side B over the sine of the angle opposite that side, or you can do A over sine of A, C over sine of C, or B over B, C over C. Now, however, this only works if you're given where you can get 3 out of the 4 letters. 3 out of the 4 letters. For instance, if they had given us all 3 sides, A, B, and C, well, unknown, can't use it. Know these, don't know these, can't use it. Know these, don't know these, can't use it. So you can only use the law of sines if they give you 3 out of the 4. Other words, if they give you this, 2 sides and one of the angles, not included between the sides. 2 sides and an angle that's not included between the 2 sides. In other words, an angle that's opposite one of those 2. Or if they give you 2 angles and one side that's opposite those 2 angles. All right? So if you're given 2 sides and an angle opposite one of those sides, you can use the law of sines. If you're given 2 angles and a side opposite one of those angles, then you can use the law of sines. So let's look at some examples of doing this then. Let's take the first example that we have. And we're given that A is 20. We don't know B, we don't know C. We're given angle C is 30, angle B is 40. And we can always find the third angle by adding these to 70, subtracting from 180, and so this now becomes 110 degrees. So if we're given 2 angles, we can always find the third one. So we want to find this up here. Well, looking at the figure, this says that angle B is 40 and angle A is 30, and so that's 20, and we don't need this figure to work the law of sines. All we have to do is come down and say, hey, we got side A and we got angle A. So we can say A is to the sine of A as, what do we want to find? B, okay, B. B is to the sine of B. Now let's plug in numbers here. We have 20 is to the sine of 30 degrees, as B, which we don't know, is to the sine of 40 degrees. And now working these, you always cross multiply. This times that is B sine of 30 degrees is equal to this times that. 20 times the sine of 40 degrees. So therefore B is equal to 20 sine of 40 degrees divided by the sine of 30 degrees. And so now you take your calculator and you punch 20 sine 40, division, sine 30, enter, and you get B to be 25.711 or whatever. Okay, now, textbooks will probably say this answer is 26 because over here your numbers are no decimals. Your side here is whole numbers, so you can say then B is 26. It's whatever the teacher wants that you to do. With calculators, you got the answer correct or however many decimals you want. All right, so we found B. Now we've got to find C. So let's look over here. Now we know A again. We know these two. And we know angle C. The only one we don't know is little c. So we'll use this then. So 20 is to the sine of 30 as C, which we're looking for, is to the sine of 110 degrees. Now, always, when possible, use numbers that are given. This one is not given. In other words, we could have used B. When we found B, we could have used 26 over the sine of 40 degrees. But we'd be using something we calculated. Well, we have to use something we calculated anyway in the law of sines. So whatever way you want to do it. You could have used B and found this over here. So we now cross multiply. C times the sine of 30 degrees is equal to 20 times the sine of 110 degrees. And therefore C is equal to 20 times the sine of 110 degrees divided by 0.5. Okay? And when you do all that calculation, you come out with 37.588 or 38, depending on what is asked for from the teacher. Okay, so the law of sines is that simple. Here one more time, then we'll work a bunch more examples. The law of sines simply says that if you know two sides and an angle opposite one of those two sides, you can use the law of sines. Or if you know two angles and one side opposite those angles, then you can find the other side. So law of sines, two sides an angle, provided the angle is opposite one of the sides, two angles and a side, provided the side is opposite one of the angles. All right, let's look at the next example, number 2. Here we're given B is 100 and side C is 70 and angle B is 80. All right. Find the other ones, other parts. Well, let's see. Here's side B, angle B. So there's that. And C, and we'll go find angle C. Here we have two sides and an angle opposite one of the sides. So we'll do that then, all right? So therefore we'll do B is to the sine of B is C is to the sine of angle C. So B is 100 to the sine of angle B, which is 80. And C, we don't know. No, excuse me. C is 70, and we're looking for the angle C that we don't know. All right, good. We have 3 of those 4. Cross multiplying. Let's just learn how to do this right quick. This would then be 70 sine of 80 degrees divided by 100. In other words, this, just divide that into that. Okay. And so we go take the calculator and, wait a minute. We're finding the same angle this time, so we better take another step. We better come in here and say that the sine of angle C is 0.6894. Now we have to find angle C, which requires what? Inverse sine button, which is second sine, 0.6894, and then enter. And we get 43.580 degrees. No, yes, no, yes. Please listen. Here's the catch to the law of sines. When finding an angle, you must remember chapter 1. Let's look right up here, for example. What is the sine of 30 degrees? Sine of 30 degrees is 1/2. What is the sine of 150 degrees? Sine of 150 degrees is 1/2. So when we go reverse this, we say, okay, what angle is equal to 1/2? There's two choices, 30 or 150. Now, this is where you have to know your trig, and your calculator doesn't work. It will not give you that 150. When you punch inverse sine buttons, it's going to give you an angle in quadrant 1 or the angle in quadrant 4. It's not going to tell you the angle that's in quadrant 2 or 3. So therefore, what we must do down here, coming back down here, is to say this. C is equal to this, or subtract it from 180. Let's just forget this, round it off to 44. Okay. So let's say it's 44 degrees. So that says that angle C is 44 degrees or what? 136. So it's possible we might have two answers. And this is what happens in the law of sines. You can get one triangle, one set of solutions, or two triangles, two sets of solutions, or no triangle, no solution. And that's what we're going to look at in the next 3 or 4 examples after this one. Now, back to this one, 136. Now, why is 136 can't be true? Because, look back over at the B angle is 80 degrees. So 80 and 136 adds up to more than 180 degrees. So this one gets eliminated because it won't match up with the given numbers. But again, hear me one more time, then I'm going to work some more examples. Anytime you do this inverse sine of a number and you get an angle, you must say that angle or and its supplement. You must subtract that from 180 and say, hey, it's possible that we may have to deal with two triangles here. So that's the caution on the law of sines when people just make up numbers. That when you go punch a button here, then you must angle or its supplement. Okay, now let's look at some more. Finishing the problem, we want to find little a and angle A. Well, now remembering now, angle C was 44 degrees, basically, rounded off. So we have B, angle B is 80 degrees. So that's 124. So therefore we can subtract that from 180 degrees and we get angle A to be then that 56.4. Okay, or just 56 if we were not rounding off type of thing. All right, so that's once we find one of the angles, then we have two of them, subtract from 180 to find little a, then we will say, all right, now that we have angle A, we'll say A is to the sine of 56.4, as B, 100, is to the sine of B, which is 80 degrees. And therefore A is equal to 100, cross multiplying, 100 times the sine of 56.4 divided by the sine of 80 degrees. Now, please hear for accuracy, here's how you handle all this stuff. What you do is when you calculated the angle, okay, C, when we calculated the angle C, which was 43.58. Save that. Put it in storage. Even though we round off and writing it down here on paper, put it in storage and keep that. And then when you come back here and subtract that from 180, add this to it, subtract from 180, you get this new angle here, keep that in storage. And then when you go calculate this, go get 100 times the sine of, recall that answer, correct to 8 or 10 decimal places, divided by. So keep these calculations, even though we're putting down rounded off numbers on pencil and paper, but keep it in the calculator and recall it. Looking at example 3 on the second page there of the notes. All right, we're given that A is 40, B is 42, and angle A is 110 degrees 36 minutes. So we'll just change over to decimals from now on, just work with decimals. What happens when they just make up numbers for triangles? Things like this can happen, all right? So we have a triangle here where this is 110.6 degrees, and we have one side given that's 42, and then the side opposite the 110 is 40. So let's see what happens. A is the sine of angle A, as B is the sine of angle B. We have 3, so therefore the sine of B is equal to this times that divided by that. So it's 42 sine of 110.6 degrees divided by 42. And so the sine of B then is equal to this decimal, 0.9829. And then B then is inverse sine of that. And the inverse sine of that gives us 79.4 degrees. Now, whoa, that doesn't work. Look back at what we were given for angle A. Angle A is 110.6, and that's almost 80. That's 190 degrees. It won't work. Also, we would check here. You remember I said before in the last example that not only check 80, but we'd have to check 100 degrees. Subtract this from 180 degrees. When we go find the angle from our calculator, we have to take that and say that and or are 101. See, this would be what, 100.6. That would be 98, wouldn't it? 98 point, or 180, excuse me. So this would be 100.6 degrees. Okay? Neither one. Therefore, this doesn't work. Doesn't work. It's a no triangle. What happens is when you have 110 degrees here, and this side's going out here like this, and this one's 42, and this one's 40, it won't reach. So what happens, and you're not going to run across this very, 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 very seldom in application, but you need to know it for test and in trig class that whenever you're using the law of sines, it's possible when they're just making up numbers that you get a no triangle. And so it has to match over here. These three angles have to add up to 180, no more, no less, so on and so forth. Another thing that should tell you right off this won't work is this. I want you to see this and don't ever forget it. The largest angle of a triangle has to have opposite the largest side of the triangle. In other words, if this is 30 degrees here, and let's say this would be about 141, let's say this is 39. So the side opposite 110 has to be larger. Then this would be the smallest side, smallest angle, smallest side. This is in between. So you can double check real quick that the largest angle is supposed to have the largest side. Smallest angle, the side opposite it will be the smallest side of the triangle. That's a good check to see if things are working too. All right, let's look at example 4, another case of getting a no triangle. All right, here we have given the side A, which is 80, and side B is 154 degrees. So here's side A out here coming down somewhere. We don't know where yet, okay? You see what happens, that side A could not touch or it could just touch exactly 90 degrees, or it could be too long and touch here and over here, make two. So we have to worry about this when we're dealing with the law of sines. So let's go work it. Let's see, we have 80 is to the sine of 54 degrees. A is to the sine of angle A, as B is to the sine of angle B. Cross multiplying, we have the sine of B is equal to this times that, 100 times the sine of 54 degrees divided by 80. And so we get the sine of angle B is equal to 1.0113. Oh, no. The sine of an angle is never greater than 1. The sine of an angle is never greater than 1. So anytime you get a calculation over here and you're trying to find an angle for the sine, then this must be less than 1. So if you do that, then don't go check your work. Don't just automatically say, no triangle. Go back and double check. Well, let's go back up here. What happens is this 54 degrees is too large. It doesn't allow this 80 to reach. The 80 is not long enough to come down and reach the other side of the triangle. So therefore we get a no triangle. So you get a no triangle when you're finding an angle and it's the sine of that angle is greater than 1. Or if you find an angle and that angle added to an angle that's given adds up to greater than 180. That's the no triangle case. Okay? All right, now let's look at the next example, a long example. This is a case where you get two triangles in the problem. In other words, what happens is similar to the case a while ago where this other side over here will touch there, or it could swing over and touch in here. Okay, so what happens when you're going to find this angle? You're going to find this angle, and then if you subtract that from 180, it will be this angle. All right, so let's do that. Well, looking at the problem, we have A and C and angle C. All right, good. So we have A, C, and C. So we'll do A, which is 69.22, is to the sine of A. Well, let's see. Let's label this. Angle C, we will call what? We want this to be C right here, and this to be B, and so this is A. All right, so this is 69.22, and C, this one is 48.85, and this is 48.85. All right, and this angle is 37.2. All right, so 69 is to this angle, angle A, as 48.85 is to the sine of 37.2. So the sine of A is equal, cross multiplying, 69.22 sine of 37.2 divided by 48.85. And so we get angle A to be equal to 59 degrees. Or 59 degrees, or we have to subtract it from 180, and that will give us what, 121 degrees. Now we go back, looking back at what we started with. 59 and 37, that's okay. That doesn't add up to greater than 180. And 121 and 37 does not add up to greater than 180. So what we have is two sets of problems. So what we do is we back off and say, okay, I'm going to take the 59 degrees and go finish the problem. So I'll take 59 for angle A, put 59 degrees in here, and then go finish it. Okay, find B and find angle B. In other words, add these two together, find angle B. When we got angle B done, then we'll go find side B. Now we have to go through this process. We can't use Pythagorean theorem, a squared plus b squared is equal to c squared. This is not a right triangle. That's only true on a right triangle. So we must use the law of sines all the way through the problem. So we'll go put 59 degrees in there, And as I have in the notes, finishing that out with the 59 degrees, we find B to be 80.28. All right. Then we come back and say, okay, now let's work it using 121. So we'll use this as 121 degrees and go work it. So let's do that. Let's go ahead and finish it out. We need to find B. All right. We need to find what this is. This is B, and this is B. All right. So let's find this when it's 121 degrees. All right. So we'll say B is to the sine of, well, now wait a minute. What is it? If we're using the 121, that's 180 minus the 121 minus the 37.2. So that's 180 minus 158.2. So how much is that? That's 21.8, isn't it? So this is 21.8 degrees. So B is the sine of 21.8, as C is to the sine of C. Again, use the numbers that are given rather than numbers that you found, if possible. All right, so cross multiplying, then B then is equal to 48.85 times the sine of 21.8 divided by 48.85. And we end up with B being equal to 29.99. All right. Now, if you notice in the notes, I used A. I went ahead and used 69.22 over the sine of 121 degrees right here. Okay. So either way will work out. Okay. Now that gives us the cases where we have no triangles and two triangles. Now let's look at law of cosines. All right, law of cosines. Law of cosines. Here's the way to remember this. Don't try to memorize all this like textbooks show it. Memorize it this one simple way. A side squared, I don't care whether it's A squared, B squared, C side. A side squared is equal to the other two sides squared. If you put an A here, then it's B squared plus C squared. If you put B here, it's A squared plus C squared. If you put C here, it's A squared plus B squared. So it's any side you want to pick. It's the other two sides squared minus 2 times those two times the cosine of the angle opposite that side. Notice B squared, A squared, C squared. It's AC, cosine of angle opposite that side. C squared is equal to A squared plus B squared minus 2 times AB times the cosine of the angle opposite that side. Now, just memorize it that way, and you just memorize one memorization for the law of cosines. It says any side squared is equal to the sum of the other two sides squared minus 2 times the two sides times each other times the cosine of the angle opposite the side that you started with. Now, the law of cosines is only good if you're given 3 sides, because you can plug it here, 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 and here and go find the angle. Or if you're given 2 sides and the angle that's included. Listen closely. That says if you're given side A, side B, and angle C. Side B, side C, angle A. So the law of cosines is only useful if you're given 3 sides or 2 sides and the angle that's included between those 2 sides. Now, the good thing about the law of cosines is it's always going to work out. You don't have to worry about 2 angles. You don't have to worry about no triangles. It will work with one and only one solution. All right, let's look at the first example doing the law of cosines, number 6. All right, we're given side A, 5, B, 4, C, 7. So we're given 3 sides. So we'll just pick any one. I'll just pick A here. So that'll be 5 squared, 4 squared, 7 squared, minus 2 times 4 times 7, cosine of A. So we calculate 5 squared is 25, 4 squared is 16, 7 squared is 49, 2 times 4 times 7, that's 28 times 2 is 56. Add that, subtract it from that side, you get a minus 40 equals a minus 56 cosine. Dividing that, you get cosine is 0.7143. You just hit the inverse cosine button, and there's the answer. And that's all there is, the law of cosines. Just plug it in, you will get that answer. Now, please don't forget, largest side, largest angle. So that means angle A is 44.4 degrees. Angle C is largest, so this angle better be the largest angle. All right, now, if you want to find the other angles, we found A, we're going to find B. If we want to find B, we can come up here and put 16. We could put 4 squared is equal to 5 squared plus 7 squared minus 2 times 5 times 7 cosine of B. And go work it out, and you get an answer. What I usually suggest, though, is now let's look at the way you finish the problem, and you finish it with the law of sines. And the only reason I do that is because it's a little quicker punching buttons. So we'll use sine of A, so that's 5, is to the sine of this 44.4 degrees that we found, as B, 4, is to the sine of B. And again, you can go hit B then, is the inverse sine of what? 4 times the sine of 44.4 divided by 5. Enter. Okay. So it can be done in less button pushing, I guess you'd say, by doing this one. But whatever. Just know that once you start with the law of cosines, you don't have to continue the rest of it. You can use it working with the law of sines. All right, so you finish the problem now. All right, let's look at example 7. Now, example 7 and 8 and 9 are some conditions that happen with the law of cosines that I want you to know about. So looking at 7, we have this. So we're given angle C. If we're given angle C, then I'm going to use C here. That way, because I know this angle. All right, so we're given an angle, and look at what happens. A, B, C, angle between them. Two sides, angle between them. If you're given B and C, it'd be angle A. If you're given AB, it's angle C. If you're given AC, it's angle B. So if you're given that, then you use the law of cosines. All right, so C squared, we don't know it. A squared would be 100. B squared would be 900. Minus 2 times 10 times 30 times the cosine of 56 degrees. All right, so this would be 1,000. C squared would be 1,000 minus all that multiplied together, which is 35.62. And so C squared is equal to the square root, C is equal to the square root of this subtracted, which ends up being 26. Okay? So C is 26, or 25.7. Again, when you're calculating these with a calculator, keep that answer in memory. Go store that answer when you get it calculated. All right. So we found C, and there's the answer to it. Now, to finish the problem, let's look down here and finish it with the law of sines. All right, we know A to be 10. Angle A we're going to find. C, again, that's from memory, okay, from keeping it stored in the calculator, is to the sine of 56. And so, therefore, the sine of A is equal to 10 times the sine of 56 divided by 25.78. And so angle A is equal to 18.8 degrees. Now, listen closely. It's not R here. You don't have to go figure the other angle. In the law of cosine, you will get just one triangle. So that's the answer. Okay? And that also checks. Looking back up here now, look what happens. Okay? C was 26, okay, approximately 26. Angle C is 56. A is 10, so angle A has got to be small, so it's got to be the 18.8 degrees. And then that leaves us angle B, around 100 degrees, which is okay because it's the largest side. So you can double check your work by paying attention to what happens. All right, now let's take the next. All right, number 8. Now what I want to do with number 8 and 9 is to show what happens when you get angles bigger than 9 degrees. What happens, you get a negative in here. And what happens, you're going to end up adding these numbers instead of subtracting them. So whenever you get the cosine of an angle larger than 90 degrees, be aware that what happens in this multiplication over here on this side is going to be added to those two numbers. And so it's going to make larger, which is true. If this angle is bigger than 90, it's the largest angle, so you should get the largest side. So these have to be added to get a larger side. All right, so just looking at all this, we're given angle B. So if we're given angle B, we use B squared is equal to A squared plus C squared minus 2AC cosine of B, and we plug in. So B squared is equal to 50 squared plus C squared, which is 60 squared, minus 2 times 50 times 60 cosine of 100. Now right here I have 6,000. Notes. The notes are incorrect. The note should have 2 times 3,000 instead of 300. So if you'll make that correction on your notes. All right. And so what happens down here when I multiply this minus times this minus, we get a positive, and we get 1,042 rather than 104.2. The decimal place on my notes is incorrect. So we should get that. So adding that, we get 7,142. Taking the square root of that, and sure enough, we get B to be 84.5, the largest side. Okay? If angle B is bigger, then side B better be bigger than the largest one over there. So it should be larger than 60, and sure enough, it's 84.5. If you have an angle greater than 90 degrees, this is going to be negative. It's going to change that and add these numbers. All right, let's look at example 9, which is saying what happens if we calculate and get a minus in here for the cosine, trying to find the angle. Okay, we'll look what we get here. We're going to find angle A, so we're going to put the 8 there, squared, 5 squared, 4 squared, 2 times 5 times 4 cosine of A, and we get 25, 16 added together is 41. Move that across, we get a positive 23. Here we have a negative. So what we're going to do is end up doing the inverse cosine of 23 divided by minus 40, and we get 125. And so, again, if this is a negative, right in here in this calculation, on the cosine, then your angle is going to be greater than 90 degrees. Okay, this concludes the tape on law of sines and cosines. Should give you enough examples. And what I'm trying to do on this tape more than anything is to show you the certain situations where you have to encounter either no triangles or two triangles, and then some of the tricks of using the law of sines and law of cosines. And let's go back to number